Here we're asked to find two derivatives. The first one is that of h of w equals w to the 5/3 over quantity w to the 5/3 plus 1. Well, it's a quotient, so let's look at our quotient rule. Lo-dee-hi minus hi-dee-low over the square and away we go. So we can move straight to the derivative. H prime of w is, okay, so lo-dee-hi means we just write the low, w to the 5/3 plus 1, lo-dee-hi. So now we take the derivative of the high. So 5/3 w to the 5/3 minus 1. Well, 1 is 3/3, so it's 5/3 minus 3/3, which is 2/3. Okay, so lo-dee-hi minus high, so w to the 5/3, d-low. Oh, whoops, times, that's times d-low. Okay, well, here we are again. So 5/3 w to the 5/3 minus 3/3 is 2/3. Okay, over the square and away we go. So all over all this stuff squared. W to the 5/3 plus 1 squared. From here we could distribute this w to this 5/3 w to the 2/3 through, but look at this. There's two of them, right? There's two of these things. So let's instead factor that out to the front and see what happens. Okay, if we do that, we get 5/3 w to the 2/3. Okay, and then what do we have left? We have w to the 5/3 plus 1 minus w to the 5/3. So I'd say that's a little simpler. All over a bunch of stuff squared, right? W to the 5/3 plus 1 squared. And then look, the w to the 5/3 in the numerator cancel out. So that gives us our final answer here of simply, we can just rearrange it a little bit. Let's make that 5w to the 2/3 over 3, then the quantity w 5 to the 5/3 plus 1 squared. There is our derivative. No further simplification. Give it a quick check to make sure we can't simplify any further. We can't, so we'll leave it at that. Let's try another one. For part B, we have y equals x minus a over the square root of x minus the square root of a. And this one's a bit of a challenge. The answer is 1 over 2 rad x. If you're up for it, pause the video and try to work it out yourself and see if you can get that same answer. Otherwise, let's proceed together. So we have y prime equals, okay, quotient rule, lo-dee-hi, so lo, rad x minus rad a, d-hi. Well, the derivative of the high, x minus a, is simply 1. All right, so far so good. Minus high, x minus a, d-low. Well, let's just do an aside real quick here. The derivative of rad x, so rad x prime, well, that's the same thing as x to the 1/2 prime, which is power rule 1/2 x to the negative 1/2, which is 1 over 2 rad x. So that's the derivative of rad x. I'm just going to go straight to that here. 1 over 2 rad x. And then over the square and away we go. So all of this goes over rad x minus rad a squared. Well, now we need a common denominator because we have this 2 rad x to deal with. So I'm going to hit this first term here with a 2 rad x over 2 rad x. Now both these denominators are going to pop down to the main denominator here. So what that gives us is 2 rad x times the quantity rad x minus rad a minus x plus a all over 2 rad x times rad x minus rad a quantity squared. Okay, next I'm going to distribute this 2 rad x through to both of those terms. So that gives us 2x minus 2 rad x times a, inside the radical minus x plus a all over that same denominator. 2 rad x times a quantity, rad x minus rad a squared. Well, we can simplify this numerator. We have 2x minus x, so that leaves us with x minus 2 rad xa plus a, again over the same denominator. But note that that numerator is now a perfect square trinomial, right? It's of the form, let's see, how about if we write it as a squared minus 2ab plus b squared, which we can simplify to a minus b quantity squared. And you may be like, I don't quite see it, but check this out. When we write it in its binomial squared form here, we would have the quantity up top now rad x minus rad a quantity squared, all over that same denominator. 2 rad x times the quantity rad x minus rad a squared. And if you don't believe me, just expand this numerator again and note that you'll get the same thing as we just had. Okay, now we have our wonderful cancellation, leaving us with our final answer of 1 over 2 rad x.